So much for theory and small-scale developments. But how do these systems work on a larger scale, which can have many more complexities?
The Dunfermline East Expansion Area is an area created to take 5,000 houses, a 36-acre leisure park, a new Tesco superstore, community centre, 3 new schools, and about 3.5 million square feet of industrial and office space. The problem with the Dunfermline East Expansion Area was that all the burns which drain it feed into the Keithing burn, which had flooded for 4 years previously because of the amount of development that had taken place upstream. And the East Expansion Area couldn't take place unless we found a solution to it. We use nature to do the job for us. And the water, instead of going into the normal gully pots, which require cleansing, goes through the holes in the curbs into a filter drain. That filter drain then leads into a swale, and is held in those swales, again in storm conditions, retaining the water to the same rate of flow at the outlet as it was when it was a greenfield site. One of the other forms of source control that has been used is on the new Tesco supermarket site, where they've used what is called form pave, which is a block pavier with gaps down the side so that the water flows between the block paviers into a gravel substrata. Just ahead of us here, there is one of the innovations that we introduced in the middle of this large roundabout on the dual carriageway. We put in one of the attenuation basins, and it takes all the drainage from the roads and it holds it there for up to 12 hours after a storm before it gradually drains away down to one of the other treatment ponds. All the drainage from the area drains through some attenuation basins into the treatment pond, where the water stays for 14 days and pollutants like oil are degraded by the organisms in the water. In the summer we found out that the water in all the ponds was crystal clear, except for one occasion when one of the contractors washed out a ready-mix concrete truck on his site and it washed down into the inlet to one of the treatment ponds. It was immediately visible and we could trace it back and find the culprit. That's one of the benefits of this type of drainage. You can actually find out the source from which the pollution is coming. And we're very conscious of safety, so the design of all these treatment ponds which hold permanent water is done in such a way that we prevent the possibility of young children straying into them. If kids get into a culvert and there's a storm, they're trapped, they get drowned. Where there is an area of still water, we have used very shallow banking in the pond itself, and before they can get to the bank, they've got to go through some pretty jaggy, impenetrable planting. So with these built-in features, we reckon that it's as safe as it should be. From the developer's point of view, now the infrastructure is in, the value of the land overlooking these structures is greater, the saleability of the houses is quicker, and the prices achieved are greater. As part of public open space, they are attractive and they're doing the job. Without them, Dunfermline East Expansion Area could not have been built.
Here alongside the M40 at the Oxford Motorway Services area, the developer used SUDS techniques in the construction of the new services. The original proposal was to discharge surface water via a 1-metre diameter drainage pipe to a river some distance from the site. But the employment of SUDS techniques meant the outlet pipe could be reduced to a mere 150 millimetres and discharged to a small nearby stream, with significant cost savings.
Probably this is as densely used a site as you could imagine, with more opportunities for pollution, more opportunities for damage than you would expect on, say, most commercial sites or housing areas or whatever it is. So there are a number of collecting systems which collect the surface water runoff as it comes down. You've got the roof system, and that's collected in a series of ponds round the building. they're used both as, for ornamental reasons, but they're actually doing a job as well in picking up the roof water. This is called an interceptor pond, and what's happening here is this is picking up all the water that is either going into the car park, which is picked up in porous paving, or it's picking up water around the HGV park and the road systems into infiltration trenches. The water that goes there, which may be polluted with oil or other substances like orange juice or milk, depending what comes down, a lot of the HGV vehicles drop things like hydraulic fluid or brake fluids onto the hard standings. Those trenches begin the cleaning process, and the longer the water stays in them, the longer the cleaning process can go on. Eventually, it comes into this interceptor pond. It stays here, there's a retention time, if you like, which allows the pollution to be broken down, either be it oils or other forms of organic pollution. The water is collected slowly, it's cleaned on its way through the system. So before it actually leaves this site, it's essentially clean, and it's leaving this site, as it were, as though this were a greenfield site. So it's designed to take the water to the, if you like, the discharge point into the natural watercourse, as though this development hadn't occurred. But these systems are hugely resilient. So even if you get a big spillage, they can break it down slowly, and if the worst comes to the worst, there is a series of systems here. So if the porous paving doesn't get it, if the infiltration trench doesn't get it, then this interceptor pond will get it. In absolutely worst case scenario, it can, even if it bypassed this system, it would go down a floodway swale, and that would trap it. So you've got every insurance policy that you could imagine in these sustainable urban drainage systems, which you don't get in conventional systems. And if the worst case occurs and the whole thing floods, as it did on one occasion because we'd had a very severe storm one weekend, the landscape can take that. Whereas, of course, a pipe can't take that. Once a pipe's full,
When taken together, the arguments for using SUDS techniques are overwhelming. Controlling water quantity, improving water quality, and developing amenity value at the same time. The techniques and advantages are well proven, and technical guidance is available.
I think it's a good thing. I think we will see better developments, more attractive developments, and most importantly of all, much less pollution.
Well, all the benefits together add up to sustainable development, and sustainable development is looking at the benefits not only to the environment but to the development, the economic regeneration of an area and to society as a whole.
The landscape, the water environment, the wildlife environment, all of these things benefit from SUDS systems going in.
Social, economic, environmental benefits. Put those together, you've got sustainable development. It's common sense.